work. But
Wait, is it supposed to be in graphing or?
well, do you have a grid?
It shows a grid.
It shows a grid. So then if you tap here or you click here, I can't drive this thing from here so well. But if you click on this, then you should have, because I don't have my grid now, you should have a little icon in here that looks like a grid, and if you click on it and drop down, you can make your screen clear.
I think I got it.
Yeah, you got it. Anybody not?
What are you doing?
Okay, so if you click on this, yeah, there's your clear, there's your XY axis. You can click on that to get rid of your XY axis. Anybody else?
No.
Now it's-
Oh,
Accidentally made a turn. I don't know.
There's like a thing that we it's go away.
I don't have any electricity.
Try putting it
Salad.
in.
Art is now.
You did that, that's right.
It's all bad since you guys
Yeah, because Natalie was doing it.
helping me.
Okay,
This Max facing off. This Max facing off.
are we, yes, Matt?
So I just like put all my tabs and everything, and I'm trying to update it, but it's still saying
This
that.
Max just
No,
What just happened?
Okay.
Oh,
Wait, Art, does yours look
I'm
like
not
mine?
gonna touch it.
Take them one at a
Oh,
time.
what have I done?
Art, it's supposed to look like this.
Yeah,
come on.
good luck, Sally.
You know, do that again.
Can I fix it for you?
Yeah.
Force quit. You will not be able to force quit and find you. Okay? And sometimes it actually just starts doing it. What happened?
I don't know.
Okay, so here's what I do. I would go Command Q, and I would say, no, I don't want to save it. Click, don't save, and just reopen the application. When it gets that bad, and we're doing something this simple, then it's time just to bail and start it all over again. Okay. So once you have this segment here, you can do all kinds of things with it. I'm gonna end up, that would have put a second one on there, shoot. I gotta be careful on the smartboard. And you can do a back arrow just like on any application. And you can go back and go forward. So once we have this here, we're actually trying to do something. Now what we're gonna do is we're gonna put a point on AB, and they say to label it C. So if you come back up to the top and you click on the point, then what we're gonna do is, if you get your pointer right on the line, you see how all of a sudden the finger comes up and you click, and there's C. And if you go back to this arrow, now you can move things around. You can move C along here, and you can move A over here if you wish, and you can move B as well. But what I want you to see with this is all of this information on the left, which at first is a little bit confusing. This here, this is just the location of A. It's negative 5.98 to 0.7. So that's if it was on the XY axis. We're not concerned with that. We're just concerned with lengths right now. Because what we've been talking about is we've been talking about segments and coordinatized lines, and the fact that from A to C, if it's added to CB, that should be the sum AB. And this information over here helps to show us. So here's F. They label this entire segment F. Is yours labeled F also? G? It's probably because of different sequence of clicking and building and maybe removing and adding. But for the most part, they name them very similarly. But here's the segment name in the lowercase. And then it says where that segment goes from and to. It has the 2 points right here. And this is the length, it's 9.64. So that's the entire length. If I want to know how long it is from A to C, here's what we do. Come down to the input, click on this, and all we type is capital A, capital C, and that's the measure of A to C. So the measure of A to C, hit the equals on your keyboard and hit enter, and now it tells you how long your smaller segment A to C is. Does that work for you? Yes? No? No? You gotta speak up, okay? I'm assuming if I don't hear anything from you that you're able to do everything I'm doing up there. Okay, so you just click on the input, and then AC, capital A, capital C, equals, and hit enter. There, so that just told you, no, because you don't have C out there. You got D and B.
Oh, no, I have it.
That's D, where's A?
Where is it?
Yeah, I don't know what happened here. Yeah,
Maybe just
He's on
redo
the
it?
line,
Boom.
though, not a segment.
yeah.
Maybe just redo
Ooh,
all
you
of it.
created a line, is what you did.
You just delete the line.
Yeah, you created a line. So, yeah, and then there is Photoshop. Okay. Yeah, put a shortcut down here though. Now, when you do the segment, what you've got to do is you got to click on this and then not do a line, but rather do a segment. And then when you go A to B, there it is. Cool. Now add a point C into the middle of it by going to that icon on the left of the lines and the segments. How about back here? Can you do this?
Yeah.
So now you have A. So the way you want to build this, you want to segment. So go click on this here. Yep, and put on segment, click, hold right on A, click on A, and go right over to B. Now it should be, I think it's on there. So now go over to this little point thing, which is the document A, click, put on point, and then hold right on that segment. Click, there's your C. Okay, so now you have the length of AB here, and then your input can be A. Oh, what did they call that? Yeah. Well, it is C, I'm just looking at that. Okay, so now just type in capital A, capital C equals, and hit enter. Now it just measured AC. And then you can do CB also. So if you haven't done CB equals to find the length of that, put that into the input over on the left as well. So you have so your ABC, that's the order that you are. Okay, so yeah, the order of your points comes up different, then you gotta be thinking a little bit differently about what you're calling your segments. So you're all good? Okay, ready to come on, anyone else?
How do you put in CD equals?
Okay, so you have A, C, and B, right? You get a bunch of extra stuff, don't you? I don't know, you're clicking all over the place. Don't click unless you're certain what to do. Log over here, click on input, and you type. Okay, you don't have a segment here.
What?
The mouse click on it if you want.
So,
Yeah.
here's what I'm gonna do.
Yeah, press that.
I'm gonna get rid of that. And then what we're gonna do is we're gonna
Oh.
bring this
You want
down.
to do
Oh.
And then when you put one out, when you put a segment out here, use this. So click on that, and then click, click.
I didn't mean to do
Click on
it.
segment,
I was
then
just trying to
click,
breathe.
click. And I'll go back to
You
point.
swallowed down the wrong pipe, didn't you?
Go to point. Click on it, drop down point, and now hold it right on the line and you get point C. There, now in the input, do AC equals and CB equals.
My face is like, oh.
Okay, so you, oh shoot, that's not what I wanted. If you don't want something that you type in here, You go to those dots and you can just delete it and start again. So capital C, capital B is equal to, and then, there we go. So now, if you have in here the length of AC and the length of CB, that should be from here to here and from that point out to the other end of the segment. So now what you want to do is add those two up. So what you can do is come down to your input in another place and type capital AC. So that's segment AC, and then the plus, and then CB. And hit equals and hit enter. And this is going to give you the sum of those smaller segments. So what I typed in here was AC plus CB, from here to here, from there to there, added together. Yes? You guys have it? So then the big question is this. Mine is 9.64. That's the same as this segment AB. Are yours the same? When you added these two segments up from those two, is that equal to the segment from A to B? It should be, right? And that's what I gave to you yesterday. That was one of the, gosh, what was it? It was like a distance postulate or something. The distance on a segment postulate that said that if you take two segments and you add them together, as long as they're in a straight line, they're equal to the sum. So, you know, two pieces are equal to the sum. You know, for example, if I had these two lengths and I put them together, this length plus this length, they add up to one another. That's all that said. Okay, so let's see. Can you drag? If you highlight this box up here with the cursor, the pointer on it, can you drag C along this edge and see how this length doesn't change, although the length of the two smaller segments does change? They want you to see that you can do that. At the same time, if you move one of the endpoints of your segment, the sum of the two smaller segments should still be equal to the total length. So, make a new screen. The fastest way to do that, I think, is just to close that and open it again. And then when you're working with Geogebra, you can get rid of the grid, you can get rid of the X and Y axes, start with a clean screen. Okay, so this time what you need to do once you have a clean screen is construct 3 points. So in geometry, when they say construct, on a DGS like this, digital geometry system, basically what you're doing is you're choosing to click and create a point or a line or a segment or a polygon, whatever you need to do. But in construction, in traditional geometry, that means using a straight edge, not a ruler, but just a straight edge, a drawing compass, and a pencil and paper, and that's it. So these things are a little bit different. It's kind of magic. They're cool in some respects, but they're a pain in other respects, because you're learning a whole new language of dealing with things. But I think it's good to see them, because if you go on to trade school or you go on to college somewhere, inevitably you're going to see something like this if you do anything that's sciencey and mathy, or engineering type stuff. Architects, for example, they start with their ideas on paper, but when it comes down to real drawing, it's all done electronically now. Everything is. So just seeing how some of this kind of stuff works, it's more of an exposure. Most of the year, we're gonna work on paper, because in the end, it's a lot less frustrating. But I do want you to take a look at this stuff a little bit. So create 3 points, A, B, and C. It says construct them. So if I highlight this, go down to my point, all I gotta do is click 1, 2, 3 times. Now, they're not segments, but we can still measure the distance between them. So if you got a ruler, you just put a ruler there. And what we're gonna do is we're gonna go to the input. So if you input, don't forget capital letters from A to C is equal to. And so that's gonna act as though there is a segment along there. It's gonna measure in a straight line. It's gonna tell how far it is from A to C. You do the same thing for C to B. Measure from C to B. Anyone want help? Or is it happening now? You're still waiting, huh? Sorry. Okay, so I'm gonna start moving C around. Oh wait, oh, I'm sorry, back up. Add AC and BC together. So you're gonna add to come up with those two imaginary segments in length. AC and CB. So AC plus CB. And then it's going to tell you how long it is right here. Mine's 10.41. All of ours are going to be a little bit different. So now move C until you get the sum of these two distances to be as small as possible by only moving C. Yeah. So now you're going to move C to get the sum of the distances as small as possible. So where does it end up? How would you describe its location?
In the middle.
In the middle?
Between
Between, yeah. So it should be anywhere along that imaginary line between A and B, right? Or really, really close to it. So the idea between this is a point is in between two other points. If you minimize the distance that it is to each point. So the distance from here to here and there to there is at a minimum when C is in between them. Okay, start with a clear screen again and make a triangle ABC. You know, there are not too many points here. I'm just going to get rid of mine by deleting them. And then when you get triangle, you want to choose a polygon. If it's regular, it's going to be all the same length sides, equilateral. We don't need that. If it's rigid, we don't want that because then we won't be able to move the vertices. And we don't want vector because we don't know what that is yet. So just go down to polygon. And if you go click, 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 then you have to go back to home for your third spot. And then all kinds of information immediately falls into place. So, you know, it tells us here that ABC, that polygon, I think it has an area. That's your area. It tells you how long each of the sides are, and they call the segments probably A, B, and C. And it'll tell you that segment A goes from point B to point C. There's a lot of naming that happened really fast that we haven't even talked about yet, and don't be too concerned with it. It'll eventually come into play. But we've got 3 vertices. And we've showed how long each of them are right away. They measure them automatically. So we have everything measured. Go down to your input and add the sides AB and AC together. AB plus AC. Does that go okay? Okay, so what's going on is we've got this side and this side are being added up on mine. Yours are maybe different. How does the sum of these 2 sides compare to the third side?
Has to be greater.
It's greater. It has to be, or it is?
It is.
It is, and it has to be, right?
Yeah.
Yeah. So do this. Move, if you click back on the cursor, drag that point, that common point down here. Let's see, I did A, B, and AC. Drag that common point around and see, does this value here, the sum of those 2, is that ever, so if we're moving this vertex, is the sum of these 2 sides ever shorter or equal to the third side? So I'm looking down here, the third side for me goes from B to C.
It can be equal.
And B to C is going to be this one right here. Can they be equal?
It's not a triangle though.
It's not a triangle though, is it? Because you drag it down and you make it touch. When they're equal, now you just have segments on top of one another, right? So that's something that we did back in middle school. If you took any 2 sides of a triangle, like these, the orange and the pink side here, it's longer than the blue side, right? Does that make a triangle? Yeah, you can do it. This one here, the green and the blue, is that longer than the yellow? No, this one isn't. Can I make a triangle? Yeah, it's not long enough to reach. Can't make a triangle. So you pick 2 sides and it comes up shorter than the third. Not a triangle. This one here, yellow and green, longer than orange. Can you make a triangle? Yeah. 2 reds and a pink. That works too. We could do that for a little while, right? That's the triangle sum inequality. And basically what it says is, if you took any 2 sides of a triangle, they will add up to being longer than the third side. Always. And it's good, but you have to be able to take every combination of that. So it gets a little confusing if you're checking to see if a triangle works with 3 given side lengths or not. So what I would suggest you do is, if you pick a triangle and you know the lengths of the sides, if you take the 2 shortest sides and you see if they add up to being more than the third side, then you can see if it would make a triangle or not. So what if you had something like this? 18, 16, 14, is that going to make a triangle?
Yep.
So these are the 2 shortest sides. Does that add up to being greater than? Yes. How about this? Is that going to make a triangle? And I take the two shortest sides, and it adds up to more than this. But if I had something like this, 2, 1, and 50, is that going to make a triangle? No, because 2 and 1 don't add up to more than 50, just because these two add up to more than that. So you have to pick all combinations. So how do you show your work with that? Here's what you can do. If you're given 3 side lengths, what you can do is this. You can, like these 3 here, you could just write an inequality and say, well, 18 is less than 16 plus 14. Therefore, you can make a triangle from it. Now, I guess in a perfect world, you would write all 3 possible inequalities. But if you can pick the 2 short sides and say that they add up to more than the longest side, then in practice that's going to work. And then if you wrote 16 less than 18 plus 14, and 14 is less than 18 plus 16, that would be all 3 circumstances being met. So this one right here, all you have to do is say, well, 2 plus 1, is it longer than 50? If you put a slash through that, that means that it's not. Just like with the equal sign, if you put a slash through an equal sign, it's not equal to. A slash through the greater than means that it's not greater than. So you can show your work that way. Yes. Sure. Okay, that's all I have.